And Thomas, we heard a lot that these norms are really crucial and also practical and should be used and should be taken advantage out of that. What norms would you really prefer in that field? What are the, let me say, the best fit norms for these approaches?
During one of our workshops, Helene Ziegler from BSH, she gave us a very good overview over the standard that they are using in the consumer IoT field. It's the ETSI EN 303645. I have to read it. It's such a long name for a standard for consumer IoT. And I think that has some aspects that could also be adopted for industrial settings. It wouldn't be my preferred standard to start with, but for industrial applications. But there are already some interesting learnings in it. It's, of course, the systematic approach. It's the definition of processual and technical requirements in the beginning. And it's this considering the whole life cycle. So there are some key elements that we also need for industrial application. Looking at industrial applications, I would see two standards. The first, this is my kind of all-time favorite. It's the ISO 27000 series. And a second, which was in our workshops introduced by Fraunhofer ISAC, they gave a good overview over the IEC 62443. And so this ISO 27000 series, for me, it's the Swiss Army knife and has some things that are also important for product design and for secure operations. Just to name two of them, it's the continuous improvement, it's the PDCA cycle, which is, from my perspective, never old-fashioned. You can, everything follows this continuous improvement process, and you can do it in a standard way, you can do it in an agile way, but it's all about continuous improvement. And second is this risk-based approach, to say, look, we don't need the same security measures for every situation, for every product, but it depends on the risk situation, on our attacker models, on the threats, and on the use case we're looking at. And this is an idea that is, I think, very well adopted in this IEC 62443 standard. They have the idea of security levels. So for every product that you want to design or for every industrial solution, you take a look at what are my security requirements and what is my target security level. And then you get a kind of a big box of building blocks and recommendations and approaches to achieve those security levels. I think that's exactly the way to go. We don't need the highest security level for every component. It's simply not realistic in a productive environment because the demands also for operations would be that high. But we need to be clear, and that should be clear for the company that is providing solution and also for the users of a solution. What can I expect from that? And so I think that's a nice idea. By the way, the VDMA for mechanical engineering, they recommend it to, as a standard to target security level 2. Yeah.
It's not only a standard, it's also a common language among different partners and companies to discuss security aspects.
Definitely a benefit. I agree, Robert. Yeah.
And Thomas, what I also liked on that scheme was really this iteration model, which is always behind that. You define your security level, you draw measures, and at the end you validate that. Are these measures led to the goal I had, or do we have to improve that? So this approach, I think it's quite common. There's a lot of knowledge from the quality management world, also, let me say, flown in the security scheme.
It is, and I think glad you mentioned that, because I think that's where, especially in industrial companies, we have a lot of experience in quality management, in processes. There are so many demands, for example, from the safety area. Yes. And so in most companies, we already have existing processes, quality gates for such things. Yes. So it would be good to combine that and use the existing mechanisms, not to add completely new security things.
New processes which are bringing more bureaucracy. That's necessary to integrate that.